Namaskar, this is Suraj Singh, professional engineer. About earthquake management, I'm just going to discuss few videos, and this number one regarding the lithosphere. You can see this drawing here. This drawing is about lithosphere indicative model for refreshing. This was prepared for presentation into a seminar. You can see the white face of this on the Excel, and this is the Excel format on which you can see this. Just for clarity, I'll go back to the AutoCAD model. So let's go back. Lithosphere is the solid part of Earth, and Earth is equal to lithosphere plus aerospace. Lithosphere is about, you can see the parameters of the lithosphere which are available in applied geology. This is the diagram, model diagram, just indicated. I have not taken the extended diameter on the North and South Pole, but with just indication here. And if you see this saying, I just blow it up. It's blown now. It's giving lithosphere indicative diagram, model diagram for refreshing, and aerospace is about 20 kilometers, while 20 kilometers from the surface of the Earth, while lithosphere is approximately 12,000 kilometers, though it's more than 12,000 kilometers, it's 12,600, but I just take it for the purpose of explanation. It has nothing to do with the actual diameter of lithosphere. There are three positions in this. You see, this is crust. Crust is number one here. This is the surface of the Earth, and this let's say crust is about 35 kilometers, according to information available in geology. Some people call it about 70 or 75 kilometers. So, well, it doesn't make a difference. Just for the purpose of understanding, I am saying this is 35 here. This is crust, and if you go down, then there is here mantle. Number one is crust. Number two is mantle. Second layer of crust. Of lithosphere, and after that is up to the center of Earth, center of lithosphere. That is called number three, and it's core. You can see inner is the core, outer is the crust, while in between the two is mantle. This is lithosphere. This is just gross understanding of that. Let's go now to further properties of this. You can see this from surface, crust is 35 kilometers, let's say, mantle is 35 kilometers to 2,500 kilometers, and core is 3,500 to 6,000 kilometers. And I've just added further properties of these. Just to consider the crust material is 2 to 5 kilogram per cc, or 2,500 kilogram per cubic meter. That is minimum temperature while it is solid state. Let's consider for the case of mantle, and this 35 kilometer onwards to 2,500 kilometers, approximately is 5 to 8 kilogram per cc, or you can say 5,000 to 8,000 kilogram per cubic meter. So medium temperature and semi-solid state. While we go further down to core, we consider about that is 3,500 to 6,000 kilometers. I'm sorry, it's 2,500 actually. By mistake, it's there. It's onward up to 6,000 kilometers. Maybe I make a correction on this, and it is actually 2,500 to 6,000 kilometers, and that's what is core. And this 8 kilogram or 8,000 kilogram per cubic meter, highest temperature it is. These are the general parameters about lithosphere, and we consider sea up to 4 kilometer depth, while ocean up to 10 kilometer depth. This is general consideration. How to define sea? We can say any water depth, any water body depth up to 4 kilometers from sea level can be called sea, while for ocean it can be 10 kilometers. This is how I just calculated the weight of the lithosphere. It's just for the purpose of understanding, nothing to do with geology or nothing to do with earthquake science. Let's say pi, this volume is kilometers 12,350 pi. This one volume is this, and dense is 4.5. Average, keeping all these three, 2 to 5, 5 to 8, and 8 to 4.5. Let us consider this, and this is the weight here, 4.44 into 10 to the power 12 tons. Is in tons. Now, the question is about earthquake, and that's most important here. Release of strain energy, we call it according to earthquake occurrence. Yes, strain energy. There are basic principles like heat from core. Heat from core thermally impacts forces mental material to move into the crust or to movement into crust. From where molten magma moves out to surface, or molten lava moves out to surface, and due to convection motion by cooling enters back to crust. Such process cycle continues. Energy releases due to disturbance. Disturbance of what? Disturbance of plates. There are 15 plates, continental plates, tectonic plates around the globe. All plates keep on moving in either direction, spatially, and they work according to that physical dynamics. We call drifting of continents also when plates move. Drifting of continents. Mountain building process. Shortening of Earth's crust due to cooling and contraction. Disturbance of mass distribution on Earth and surfaces as a result of erosion of highlands and deposition of sediments in the sea. Generation of heat by radioactive material inside the Earth's crust. Ocean base works same principle, same process. Energy is released on ocean beds. Energy is thrown out throughout kilometers. Volumes, tsunamis are resulted. Another note on this is convection motion. Let us see slips at falls, push and pull of plates, strong vibrations due to release of strain energies means earthquake, magma, lava, volcano. There are bodies waves, there are surface waves. Body P waves and S waves, surface low waves and relay waves. There is tsunami as well. This is the description of tsunami, how it works. This is actually tsunami here. This is the ocean, and this is the appearance of tsunami. This is the continental plate. This is a tectonic plate. When tectonic plate comes down, continental plate on that, and this is the creation. There's a speed of about 700-800 kilometers of water flow from thrust from the core and from the mantle, and there is a water flow with that speed, like a plane is moving vertically, and you can say this tsunami, when this speeded water, this high velocity water reaches the beach and strikes with the low velocity water, there's a jump creation, just like hydraulic jump, and this hydraulic jump is called tsunami. This is called tsunami. Continental plate, tectonic plate. Then this is the explanatory example, and I just prepared based on my thoughts. Now we'll continue the next video